Hello, Algebra 1. Today I'm going to be going over multiplying polynomials in your student journal starting on page 211. So let's go to page 211 and get started. Up at the top in the vocabulary section, I'm actually going to cross out the vocabulary word FOIL method. We'll talk about that later. And I want to talk about specifically this idea of multiplying binomials. We talked about last class what a binomial is, and a binomial is a two-term polynomial. It could look something like this, x plus 2. I'm going to put a parenthesis around it. What we are going to be doing in this first part of section 7.2 is we're going to be multiplying two binomials together. So maybe something like this, where you're multiplying two terms by two other terms. Now we know that 2 times 2 is 4. So when we are multiplying two terms by two other terms, we know that we are going to get 4 terms. So our product is going to have 4 terms when we multiply two terms by two more terms. Okay? So what's happening with this concept of multiplying binomials is we are basically distributing. Distributive property tells us that we are multiplying. Okay? So basically what you're doing is you are going to distribute each term in the first binomial, okay, to each term in the second binomial. Okay. I like to think of this as multiple distribution because that's what you're doing. You are multiplying, you're distributing multiple times within one problem, okay? And again, by doing this multiple distribution, you're going to get some terms, okay? We are always going to make sure that these 4 terms that we get, that we make sure to simplify by combining like terms. And obviously, we always want to present our answer in standard form. Remember, standard form is the idea of putting your terms in order by exponent, something that we talked about last class as well. So this is what a lot of your problems are going to look like, something specific like this. So I'm going to take this problem and I'm going to do it down below where it says notes. I'll talk about this FOIL method in a moment. So in the notes section, I'm going to take that problem. I've already forgotten what it was. X plus 4, or sorry, X plus 2 times 3X minus 4. Okay. There's lots of examples that we could give, but this is what I'm going to start with. So I'm going to go ahead and I'm going to use the this idea right here that I talked about, where we distribute each term in the first binomial to each term in the second binomial, doing what we call multiple distribution. Okay, so here is method number 1. Okay, so using that idea, I'm going to take the first term of my first binomial and I'm going to distribute it to each term in the second binomial. So the idea of distributing, we know if we just had x times 3x minus 4, we would just, do that multiplication, okay? We're going to have to do this distribution twice. We're going to do it for each term, okay? So I'm going to go ahead and I'm going to multiply x to 3x and x to negative 4. Remember that if you have x times x, that basically means that you have x to the first times x to the first. If you have same base, what do you do with your exponents? You add them. Okay, so I'm going to go ahead and do that. So x times 3x is going to give me 3x squared. Okay, and then x times -4 is going to give me -4x. Okay, I'm not done yet because I still need to multiply this term to each of these terms. So I'm going to go ahead and I'm then going to multiply the 2 to 3x and to -4. So distributing again. So when I do that, 2 times 3x gives me plus 6x. 2 times -4 gives me -8. So I want you to notice that you got 4 terms. Basically, what's happened is every term has been multiplied to every term. And because there's 2 terms times 2 terms, I should get 4 terms, which I do. But remember, after you get those 4 terms, you need to make sure that you simplify by combining any like terms and also putting your answer in standard form. So I can see that I have 2 terms that have an x, and those are my only like terms. So when I go to combine, I'm going to get 3x squared, nothing to combine with that. -4x and 6x gives me 2x. The only constant I have is -8. So I'm going to bring it down to my next step. And my final answer happens to be a trinomial. Your final answer could be 4 terms. Your final answer could be 2 terms. It could be 1 term, I guess. It just really depends on what your original problem, what you're given, okay? So this is using sort of just straight distributive property, okay? So multiple distribution, I'll call it. Now you'll see up above in the core concepts this idea of what's called the FOIL method, okay? So in method 2, I'm going to do the same exact problem, okay? And I'm going to introduce this concept of FOIL, which is really what I just did. It's exactly the same thing, okay? FOIL is a mnemonic device for multiplying 2 binomials together, okay? And I'm going to show you how it looks a lot like what we just did, okay? And the reason I like to introduce FOIL is because other teachers might use FOIL, and I want to make sure that you've seen it before. Okay, so the FOIL method is this idea of using a mnemonic device of the word FOIL to know what you need to multiply together, okay? So FOIL, or F, I should say, is the idea of multiplying the first terms together. So the first terms of each of the binomials, which would be the x and the 3x. So we know that x times 3x is 3x squared from when we did the problem before, okay? So that is the F. That's what the F stands for. The O is the idea of multiplying the 2 outside terms together. The outside terms, what they mean is they're talking about the x and the -4. So that is, whoopsies. I'll put it down here so it doesn't like cross over. So that is this one right here. Maybe I'll do that in a different color here. That's your O, okay? So there it is. And the O would be the x times the -4, which gives me -4x, okay? The I stands for the inside terms. The inside terms are the terms literally on the inside of the problem. These 2 right here. That is your I, okay? And that would be 2 times 3x, which is 6x. The L stands for the last terms, and meaning the last terms of each binomial. And so that's going to be this one right here. So the last term of the first binomial, the last term of the second binomial would be the 2 and the -4. That's going to be your L. Okay, and we know that 2 times -4 is -8. Now I want you to see the differences and the similarities here. Well, first of all, the only difference is the way that I thought about the problem. Okay, the similarities here, making that a little neater for you, the similarities here is exactly the same. If you notice, here's my first distribution, the green and the orange. Here's my second distribution, the blue and the pink. Notice that my 4 terms are exactly the same. Okay, so it's just a different way to think about it. Okay, I could again see that my like terms are right here, and my final answer is going to be exactly the same. It's going to be 3x squared. Combining my like terms, I get plus 2x, bringing down the constant -8. And I can see here, I get exactly the same answer. And this is what we call the FOIL method. Now, FOIL method is nice, but it is a trick. Okay, and tricks don't always work. Kind of like shortcuts don't always work. This really only works for binomials. So what about when you have trinomials and, binomials and trinomials, right? That's why I kind of like the multiple distribution, because it always works. It will always work. Okay. The last and final method is using an area model, or a table as they call it. So doing the same exact problem, it's this idea of using, some people call it the box method. There's all different names for it. This is the one that I am least likely to use. Why? Probably because I'm too lazy to draw the box, and I just want to start multiplying it. And using multiple distribution, I tend to be able to do the problem in my head a little bit faster. So the idea of using the box method, table method, area model method, there's all different ways that people call it. People call it a box method, a table method, an area model. All of these is exactly the same thing, okay? Call it what you wish. So what you're going to do with this method is you're going to take one of the binomials and you're going to write it at the top. I've created a 4x4 box, a 2x2 box, because I'm multiplying 2 terms by 2 terms, which means I will get 4 terms, which is why I have 4 boxes. And then here I have the 3x and the -4. This is the other binomial. I'm going to do this like a multiplication table. 3x times x is 3x squared. 3x times 2 gives me 2x. The -4 times x will come land in this box to give me -4x. The -4 times 2, like a multiplication table, would land in this box, giving me -8. You cannot leave your answer like this. You still need to simplify your answer. So simplifying my answer, I'm going to do it like I would any other problem. And I'm going to see I have nothing to combine with 3x squared. -4x and 6x are like terms, which give me 2x. Nothing combined with -8, and then here is my answer. So that's the, I think they call it using a table. And you can see that down here starting at number 7. Now, just because they tell you to use a specific method does not mean you need to use that method. You can use whichever method you want. Okay? All right. So that's an example of binomial times binomial. I'm going to go down to number 19. And I'm going to do number 19 with you. What's different about 19 is that it's a binomial times a trinomial. You can still use the multiple distribution. You can still use a table. Now, the difference is I'm multiplying 2 terms by 3 terms. If you do 2 terms times 3 terms, since 2 times 3 is 6, that's going to result in 6 terms. So if you are going to use a box or a table to do these problems, you need to create a bigger box like that. Okay? I'm going to go ahead and just do multiple distribution, and I'm going to rewrite the problem just so you can see it a little bit bigger. So let's go ahead and do this problem. Okay, so doing this problem here, the goal here is to multiply everything in the first. So you're going to distribute the first term like that. And you're also going to distribute the second term like that. So it's the same thing. There's just a little bit more distributing to do because your second parenthesis has 3 terms. So let's start with the first distribution. So I'm going to do x times x squared. Remember, that's x to the first times x squared. You add your exponents, so it results in x to the third power. X times x comes next. Pay attention to your signs. We should start to realize that x times x is going to be x squared. That will kind of start to become second nature to you. Last but not least, you still have to distribute x to the -1. X times -1 is -1x or just negative x. Now what I need to do is I need to distribute the -2. I'm going to start by taking -2 and distributing it to x squared, which gives me -2x squared. I'm then going to distribute -2 to x. -2 times x is -2x. Last but not least, you're multiplying -2 to -1. -2 times -1 is actually a +2. Pay attention to your signs. You can see that I've gotten 6 terms. I know I'm on the right track because of that. Last thing that you need to do is you need to combine your like terms. And I'm going to combine them in order, starting with my highest exponent. I see my highest exponent is an exponent of 3. There are no other terms that have an x to the third, so I'm going to just rewrite that down in the next step. Next, I have my x squared terms. There are 2 of them. This is a 1x squared and a -2x squared. So that gives me a -1x squared or just a -x squared. My next like term that I have is the x terms. So a -x and a -2x. Remember, this is a -1x. -1x and -2x is going to give me -3x. The only constant I have is a 2. So when I go ahead, there's nothing to combine with it, so I just bring it down to the next step. So this is my final answer written in standard form. You will definitely get more practice with this in your assignment today. Please come to support if you have questions, and best of luck with your practice.